Suppose you and I decide to play a lottery game. We both draw from a deck of 100 cards numbered from 1 to 100, and whichever one of us has a card with a higher number than the other wins $5. If I drew my card and saw that my number was 75, say, I can be reasonably confident that I've won, since there are 74 cards lower than mine and only 25 cards that are higher. If you were to ask me what my odds of winning were before I drew that card, though, I would have told you 50%, since the game is totally fair and there are only two of us. This game is fairly straightforward, but let's now suppose that our deck has infinite cards, one for every whole number. What would that game look like then? First, you would draw your card. Let's say it's 11 trillion and 14. And you would be absolutely certain that you've lost. After all, there are only 11 trillion and 13 cards that are less than yours, but there are infinite cards that are greater. This is true no matter what card you draw. For any possible number you can get, you are virtually certain that whatever I got is bigger. But despite your certainty that I've won, I am certain that I've lost for the exact same reason. No matter what number I drew, the finite number of cards you might have that secure my victory are always completely annihilated by the infinite number of cards that secure my defeat. So, no matter what card each of us gets, we are both absolutely certain that we have lost and the other player has won. Here, rationality pulls you and I in two separate directions. It's intuitively obvious that in a perfectly fair game between two players, each of us has a 50% chance at winning. And yet rationality compels each of us to hold our losses as guaranteed. Suppose next that I left our table to use the restroom, and to pass the time while I'm gone, you decide to draw cards from the infinite lottery one at a time. You place your first card on the table, and before drawing the second, you ask yourself if you think the next card will be higher than the first. You realize that since there are only a finite number of cards smaller than yours and an infinite number that are greater, it's statistically virtually certain that your second card will be higher than your first. This remains true for each card you draw. Once again, sound reasoning leads to two contradictory results, since it is obvious that in a perfectly shuffled deck, the odds of you drawing cards in perfect descending order are very low, and yet it's guaranteed that each card you draw will be higher than the last. These are just some of the ways in which the infinite fair lottery breaks rationality. If we wish to maintain rationality in our worldview and keep it from veering off the cliff of absurdity, then it is quite reasonable to suggest that the infinite fair lottery cannot be instantiated in the real world, and in doing so, place limits on the ways in which the infinite may enter into the causal history of the universe.